For question 5, you're supposed to express the expression in partial fractions first. So I think this part most of you can do. Okay, so once we express 1 over 3r minus 2, 3r plus 1 into partial fractions, we can now express it as a sum of a difference of two terms. When we can express it as a sum of the difference of two terms, we can apply methods of differences. Now, there's a specific way where we write down the terms, okay? Please don't write down all these terms in a straight line. When you expand out and write down term by term, don't write things like that, plus in a line, in a horizontal line. If you do that, you will not be able to see the cancellation easily. So make sure you present it as a column as shown over here, okay? So in the first row, we have r equals to 1. So when I sub in r equals to 1 into the expression, I get 1 over 1 and 1/4. So do that for r equals to 1, r equals to 2, r equals to 3. Okay, usually we will show like at least 2 cancellations for the first few rows and another 2 cancellations for the last few rows. Okay, so the cancellation has to be shown clearly here, and it is always diagonal. Okay, either in this direction or the other. Sometimes it can skip rows. Sometimes it is over, the cancellation can be done over 3 rows, where we'll see in the next example. So show the cancellation clearly, and we are just left behind with the first term here and the last term in this case. So simplifying, we have n over 3n plus 1. Now we look at the next part of the question. After we have found the sum of 1 over 3r minus 2 and 3r plus 2, they fit in the limits, okay? Down here, we know that we have to start summing from r equals to minus 2 to 25. So can I do a direct substitution? No, I can't. What is the reason? Because in my previous question, I have evaluated this. R equals to 1 to n, 1 over 3r minus 2, 3r plus 1 is equals to n over 3n plus 1. So you see that our sum begins with r equals to 1. We can't directly plug in and use, okay, this expression. So what we need to do, we have to see whether we need to add extra terms or we need to subtract away terms. So since we are beginning with r equals to minus 2, we have extra terms. What are the extra terms? The extra terms are when r equals to minus 2, r equals to minus 1, r equals to 0. Don't forget this. When r is equal to 0 doesn't mean that the term is 0. And finally, we add from the sum from 1 to 25. Okay, now for this part, I can directly sub in 25 into this expression and get the sum. So I can evaluate when r is equals to minus 2, I sub into the r value and I get 1 over 40. So on and so forth for r equals to minus 1 and r equals to 0. So finally, you get your answer. Now for 5 part 2, we are more worried about the way that you present it. So you see that we are summing from 4 to infinity. Okay, this is a sum to infinity starting from the 4th term. So how do I express this? Usually, we will rewrite it like that. Okay, limit where n tends to infinity, sum from r equals to 1 to n. Okay, we re-express it as this way. And now you see that the sum starts from r equals to 4. Okay, all the way to n. So what should I do? I need to, if I want to make use of the previous expression, okay, the previous expression begins with r equals to 1 to n, 3r minus 2, 3r plus 1 is equals to n over 3n plus 1. This was what we found in the first part. So we need to remove away terms, right? So if we sum from 1 to n, which are the terms that I don't want? I don't want the first term, second, and third. So I need to subtract away the sum from 1 to 3. Okay, so likewise, I just sub in, this term corresponds to r equals to 1, this term corresponds to r equals to 2, these terms correspond to r equals to 3. Now, so after this, okay, our expression will be in terms of n. So don't forget that we are summing up to infinity. So we have to take the limit where n tends to infinity. So taking note of this, after simplification, we actually have limit n tends to infinity, n over 3n plus 1 minus 3 over 10. Now, you see that this one, this expression, n over 3n plus 1, if you let n tends to infinity, you will end up getting infinity over infinity, which you can't conclude anything. So that's why, reminder, the last lesson, I mentioned that we need to divide throughout by highest power of n. In this case, the highest power n is n. So the purpose is to make n go to the denominator so that when n tends to infinity, 1 over n will tend towards 0. So that is what happens here when I divide every term, each term, by the highest power n, which is n in this case. I will end up getting this expression. So when n tends to infinity, 1 over n tends towards 0, which you will get 1/3 for this term. So the sum will be 1/3 minus 3 over 10. Now this last part, part 3, is the hardest one, okay, because you see that the expression that we need, the expression here is completely different from what we have found earlier on. If the expression is different, okay, listen carefully, we have to re-express this expression to be the same as the original. Okay, that means this new expression, I need to express it exactly the same as the original. So how do I do it? The original expression is where we have found is sum. The original sum is this, 3r minus 2, 3r plus 1. So now we have 3r minus 5, 3r minus 2. How do we re-express it such that it can be expressed in this the form that we have found? So by observing that we replace r by k plus 1. Now some of you, right, you replace r by r plus 1, it can get very confusing. So don't use back the same variable, okay? So you replace r by k plus 1. So in this case, the expression will become the same already. You sub in r equals to k plus 1, you get the same. Okay, same expression. Okay, that's good already. We do not just need to re-express the expression. The limits also have to change. When r is equals to 2, because r is equals to k plus 1. When r is equals to 2, we have k is equals to 1. When r is equals to n, we have k is equals to n minus 1. That's why we are summing from k equals to 1 all the way to k equals to n minus 1. So now everything is in place, the expression is the same, the sum also starts from k equals to 1. We can just do a direct substitution into the expression, n over 3n plus 1. Okay, so but we replace n by n minus 1 and we obtain what we want to get here.